Okay, remember today we are going to see how we differentiate functions to get their gradient, but please don't forget to subscribe to the channel. Now, the question is find the gradient of the following curves at given points. Now, if I'm starting with this, in order to get a gradient of a function, we differentiate that function. So, the gradient of this, I differentiate this function. Now, if I differentiate y, I'll be having y dx equal to, because I'm respecting x, when I differentiate this, I get 2. When I differentiate a constant, I get 0. So the gradient of this function is 2. And if it's a line, and so this gradient is 2. Now when I come to this, I need to differentiate y with respect to x at this point. So differentiate down is what I do. I differentiate this, I get y, and with respect to x equal to 2. When I differentiate this, I get 8x. When I differentiate this, I get 3. When I differentiate a constant, I get 0. So they are giving me a point. So now, my dy dx at a point when x, you start here, the x value is 1, the y value is also 1. When x is 1 and y is 1, now we substitute in this. So 8, where is x now? I put 1 minus 3. And so my gradient there will be a 5. Now when I come to this, it's a circle, because it's an equation of a circle. So differentiate, when I differentiate this, I get 2x plus. When I differentiate this, I get 2y. But because I'm differentiating y, whenever I'm differentiating y, we put y dx equaling 2. When I differentiate this, I get a 0. Taking this to the other side, is that my y dx will be, first of all, negative 2x, but I'm dividing through now by 2y to make this the subject. So my y dx at this point is that my is cancelling, so the y dx at a point when x is 2 and y is that from there our y is 3 will be, we substitute. Now we have negative into our x is 2 over our y, which is a 3, and the gradient becomes negative 2 over 3. So here, I'm going to emphasize this. Whenever I'm differentiating y, don't forget to put this differential coefficient of the y dx, the gradient function. Still, when I come here, so I have y and I have y. We say, when I differentiate 2x, I get 2, then plus, when I differentiate this, I'm having around this part, I'm having 6y. Because I'm differentiating y, now there I put the y dx. I'm having now the y dx. Plus, here so it's also a function of y. I'm having now 3 and I differentiate, but because I'm differentiating the function of y, I put the y dx equaling to a 0. So now we start, we have 2 the y dx. I get these gradient functions. So I take first of all to the other side and I factorize out the y dx. So this will be now, when I factorize out, I'm having 6y plus 3 into now the y dx equaling to, when I take this to the other side, I get negative 2. So I need this, I divide it through by this. So now my y dx will be negative 2 the whole over 6y plus 3. So this is now my gradient. Now they want it at this point. So now I say now my y dx at a point when x is that our x is negative 2. And then our y, from here our y is at 2. I'm substituting in this formula. It will be negative 2 over, then 6, the value of y is 2, then plus the 3, and when we simplify this is 12 plus 3, is that we shall be having negative 2 over 15. So now, the gradient of this curve at this point is this. Now when I come to this, still, it's like this one is a function of y. So I'm going to say, when I addition this, I get 3y squared. Because it's a function of y, it's the y dx. Then minus 3 now. Here I say product of two functions. There we use product rule. I made a video for that. You can check how we use the product rule. What we do is say, fix x, differentiate y. When I differentiate y, I get 1. But because it's y, I get y dx. Then plus. Fix now y, differentiate x. So the differentiate x we get a 1. That's how we use product rule. Let me repeat. You say fix x, then differentiate y. Because I'm differentiating y, I get 1 but the y x because I'm differentiating y. Then plus now this time we change. Now we fix y, then we differentiate x. When I differentiate x, I get 1. That's all. Then when I differentiate this, I get 5x power 4 equaling this side. I get a 0 because this is a constant. So now opening brackets, you see you have 3y squared dy dx minus 3x dy dx. This negative and this, you get 3y. Then when I take this other side, I get negative 5x power 4. So now instead of how do I get to here? We factorize it out. So I have 3y squared minus now 3x into dy dx equaling to. Now when I take this other side, also I have negative 5x power 4. Now this one becomes a plus 3y. Then multiply this, so see my dy dx becomes negative 5x power 4 plus 3y over 3x. So now the gradient of this function at a point, this is that our x value is 0 and our y value is negative 2. Shall be at now negative 5 into what is x, I put 0, then plus 3 into negative 2, the whole over 3 into negative 2 squared, then minus 3 into a 0. So this will be 0, this will be negative 6 over, down this will be, when I square this, I get 4 times this, I get a 12 minus a 0. So that now my gradient at that point will be negative a half. So remember, whenever you have a product of two functions, you use the product, you differentiate them using the product rule. I wish you the best. Don't forget to subscribe to this channel.